Welcome to section 4.3, L'Hopital's rule. Our goal today is to find limits of functions that are in the form 0 over 0 or infinity over infinity. So, here's our theorem. L'Hopital's rule for 0 over 0 indeterminate forms. This is when we have the limit as x goes to c being a real number, of our function is 0, and the limit of our function g going to c is 0. Then if we have our limit of f over g, then we can take the limit of f prime over g prime, providing that it exists. And this is really going to help us out because if we are trying to find the limit of f over g and it goes to this indeterminate form of 0 over 0, L'Hopital's rule really helps us be able to rewrite it in a way that allows us to find that limit. L'Hopital's rule for indeterminate forms 0 over 0 are also valid if the limit f and the limit g are both infinity. So if we get the form 0 over 0, we can use L'Hopital's rule. If we get the form infinity over infinity, we can use L'Hopital's. Any other situations, we won't be able to. So those are kind of the rules for using L'Hopital. Okay. In problems 1 and 2, use L'Hopital's rule to find the limit. So here we have the limit as x goes to 3 of x cubed minus 27 over x squared plus 2x minus 15. So what I'm going to do first is just show you what happens. My professor told me we do the dumb thing. So we plug in 3. So I'm going to have 3 cubed, because that's what x is going to, minus 27 over 3 squared plus 2 times 3 minus 15. Okay, so now we can see 3 cubed is 27. So 27 minus 27 gives us 0. And then we have 9 plus 6 minus 15. So we're going to have 0 over 0. That's the form we're looking for in order to use L'Hopital's rule. So we have 0 over 0. Now we can use our L'Hopital's rule here. And so this limit as x goes to 3 is going to now become the derivative of each of these. Now, you do not need to do this. Is the only time that you're going to take the derivative of the numerator by itself and the derivative of the denominator by itself. We are not using the quotient rule. So, the derivative of x cubed minus 27 is going to give us 3x squared. And the derivative of x squared plus 2x minus 15 was going to give us 2x plus 2. And now, let's find the limit. So, we'll do the dumb thing. Plug in 3. 3 times 3 squared over 2 times 3 plus 2. Okay, so now I have 3 times 3, 9 times 3, 27. 2 times 3 is 6, plus 2 is 8. So we have our limit. As x goes to 3, our limit is 27 over 8. And that's how we do it. We can use it for these indeterminate forms. Let's try another. As x goes to infinity. So here we have 3x to the 4th plus 17. So if you imagine, I take a number and I cube it, and then I multiply it by something and add something. So as my numbers get bigger and bigger, as x goes to infinity, and I'm cubing them and I'm cubing them, I'm just going to keep getting bigger and bigger numbers. So the limit as x goes to infinity of 3x to the 4th plus 17, as my numbers get bigger and bigger, that's going to go to infinity. Now if we look at the denominator, 6x to the 5th plus 25. So same thing, as I plug in bigger and bigger x's and I'm raising them to the 5th power, my number is getting bigger and bigger and bigger. And then I multiply it by 6, it gets even bigger. I add 25, it gets slightly bigger. So it's also for 6x to the 5th plus 25, that's also going to infinity. So this is an example of getting this indeterminate form of infinity over infinity. Let's apply L'Hopital's rule. The limit as x goes to infinity. So the derivative of 3x to the 4th plus 17 will give us 12x cubed. The derivative of 6x to the 5th plus 25 will give us 30x to the 4th. Now, before we go any further, let's reduce. So the limit as x goes to infinity, if I have 12x cubed over 30x to the 4th, we could rewrite this as 12 over 30x. X cubed on the numerator, x to the 4th in the denominator. And now let's think about this. As we plug in bigger and bigger and bigger x's, that's making our numerator stay the same, but our denominator get bigger and bigger. And what we know about fractions is if our denominator is getting bigger and bigger and bigger, that fraction is representing a smaller and smaller and smaller number. So this limit is going closer and closer and closer to 0. Okay, explain why L'Hopital's rule does not apply to the following problem. If the limit exists, find it by other means. Limit of 2x cubed minus 35 over 3x squared plus 5 as x goes to 4. So let's make sure that we can even apply it. It says explain why it does not apply. So let's begin by doing the dumb thing. Let's plug in 4. So we've got 2 times 4 cubed minus 35 over 3 times 4 squared plus 5. What do we get? Well, now we're going to have 4 times 4 times 4 times 2 minus 35. We should have 93 in our numerator. Right away we should know, okay, I'm not going to use L'Hopital because I don't have 0 over 0 or infinity over infinity right now. 4 times 3 plus 5, so we should get 53. Okay, so now we have our answer. L'Hopital's rule does not apply. Because when the value of x equal 4 is substituted in, our result is not 0 over 0. So we know that was one of the rules in order to use L'Hopital. It doesn't meet that rule. It doesn't meet that condition, so we cannot use it. Use L'Hopital's rule to find the following limit and then verify that limit by using a second method. Okay, so we have the limit as x goes to 7. This is a typo. Of x squared minus 2x minus 35 over x squared minus 10x plus 21. Okay, so it's telling us right away to use L'Hopital's rule. So let's do it. The derivative of x squared, 2x. The derivative of negative 2x, minus 2. Derivative of 35, 0. derivative of x squared, 2x, the derivative of negative 10x minus 10, derivative of 21 is 0. And now we'll have 2 times 7 minus 2 over 2 times 7 minus 10. So we have 14 minus 2 is 12, and 14 minus 10 is 4. And 12 over 4 gives us 3. So thank you, L'Hopital. Now we will verify it using another way to find it. So I'm going to rewrite our limit down here as x goes to 7. X squared minus 2x minus 35 over x squared minus 10x plus 21. So the first thing, if we're manipulating these quadratics, I always immediately think, can I factor it? So we'll say, let's rewrite in factored form. Numerator, x and x make x squared, 35 and 2. So we'll have 7 and 5. It's a negative 35, a negative 2. So minus 7 plus 5. Okay, x squared, x and x, 21 and 10, 7 and 3, negative 10, so minus minus. And now we can see I can eliminate an x minus 7 from our numerator and our denominator. So this gives us the limit as x goes to 7 of x plus 5 over x minus 3. This will give us 7 plus 5 over 7 minus 3. So we'll have 12 over 4, giving us 3. And that worked out pretty nicely. We verified, yes, it does work, and I used a different method to show that. In problems 5 through 8, find each limit. Note that L'Hopital's rule does not apply to every problem, and some problems will require more than one application. Okay, so now we're going to see, maybe I do L'Hopital's rule and it still gives me an indeterminate form, so I have to do it a second or third time. Okay, so the first thing we want to do, oh, this one is full of mistakes. Okay, this is minus. And this is a plus. The limit as x goes to negative 1 of x cubed minus 7x minus 6 over x squared plus x. So the first thing I want to do is check, can we use L'Hopital's rule? So if I plug in a negative 1 cubed minus 7 times negative 1 minus 6 over negative 1 squared plus negative 1. So this will give us negative 1 cubed is negative 1 plus 7 minus 6 over 1 minus 1. Okay, we get 0 over 0, so we can use L'Hopital. Let's rewrite. X goes to negative 1. So we'll have the derivative of x cubed, 3x squared, minus 7. Derivative x squared will be 2x plus 1. Okay, so now we'll have 3 negative 1 squared minus 7 over 2 times negative 1 plus 1. So this will give us 3 minus 7 over negative 2 plus 1, negative 4 over negative 1 plus positive 4. Okay, that one worked out okay. The limit as x goes to 2 of x to the 4th minus 6x minus 3 over x cubed plus 2x minus 6. Okay, let's check before we jump in. If we do the dumb thing, let's see, 2 to the 4th minus 6 times 2 minus 3 over 2 cubed plus 2 times 2 minus 6. So we will have 2 times 2, 4 times 4, 16 minus 12 minus 3 over 2 times 2, 8 plus 4 minus 6. So we'll have a 1 over 6. So this one doesn't need L'Hopital's rule. The limit is 1/6. Okay, next up, the limit as x goes to infinity of 7x cubed plus 4x minus 5 over 9x to the 4th minus 6x plus 7. Okay, again, let's check. X is going to infinity this time. And again, we have to imagine, okay, if my x values I'm plugging in are getting bigger and bigger and bigger, I have an x cubed, so I'm cubing these numbers, and as I plug in bigger and bigger numbers and cube them, my number is just going to grow and grow and grow. This is going to give me infinity. 9x to the 4th, I'm cubing and cubing and cubing it, and then I subtract 6 of that number. So it's subtracting it off, but it's not going to bring it down by much. So this is also going to infinity, and we have that indeterminate form of infinity over infinity. So we can use L'Hopital's rule in this case. So let's take our derivatives. 7x cubed is 21x squared. 4x will be 4. 9x to the 4th would give us 36x cubed minus 6. Now this time, if we take our limit, we plug in bigger and bigger and bigger x values, we can see it's still gonna go infinity over infinity. They're being squared, and then on the denominator, they're just being cubed. So we will take a second L'Hopital's rule. So 21x squared becomes 42x. And 36x cubed becomes 108x squared. Okay. Now, in this case, if we plug in infinity now, we have bigger and bigger and bigger x values going into our numerator, and bigger and bigger and bigger x values going into our denominator. So this is still going to go to infinity, and this one's still going to go to infinity. So we'll take L'Hopital's rule again. 42x becomes 42. 108x squared becomes 216x. And now if we plug in infinity, our numerator stays the same, but our denominator will grow and grow and grow and grow. And so that is a fraction that's getting a bigger and bigger denominator, so it's going to 0. And that example showed us that we'll have to sometimes take multiple times apply that L'Hopital's rule. Okay, number 8. The limit as x goes to -3, 2x plus 6 over x squared minus 5x minus 24. let's check it first. 2 times negative 3 plus 6 over negative 3 squared minus 5 times negative 3 minus 24. And so this will give us 2 times 3, negative 6 plus 6. 3 times 3, 9 plus 15 minus 24. 0 over 0. We can use L'Hopital's rule. And so our limit as x goes to negative 3 will tell us the derivative of 2x is 2, and the derivative of x squared, 2x, derivative of 5x is 5. So this will be 2 over 2 times negative 3 minus 5, 2 over negative 6 minus 5, negative 2 over 11. Okay. And for the final thing, I just want to show an alternative solution. If we didn't use L'Hopital's rule, so we have 2x plus 6 over x squared minus 5x minus 24. Then I would use my factoring method, as I mentioned before. In the numerator, I'll factor out a 2, so I have x plus 3. In the denominator, when we factor, we'll have x, let's see, 24 is 3 times 8, negative 5, negative 8 plus 3. And in this case, it will become limit as x goes to negative 3 of 2 over x minus 8. And so we'll have 2 over negative 3, negative 8, negative 2 over 11. Just to show we can still get there, almost verifying our L'Hopital rule.